Okay. Hi. So today we're gonna look at the Bozo sort, which is an algorithm for sorting, and some consider it to be the worst sorting algorithm ever. Some consider it the best. There's no consensus, and the thing is that there really is no middle ground. It can either be the best or be the worst, and we'll see why that is in a second. So Bozo sort essentially is a very random sorting algorithm, and actually it's a close counterpart of a second kind of algorithm that is called Bogo sort. And the two of them have a very small difference, and we'll look at that difference a little bit later. But the way that the algorithm works is let's go ahead and get started here and write our pseudocode. Let's say this is an array, it has 4 elements and it's clearly not sorted yet. And how it works is it'll iterate through the entire array, and as long as you know the array is unsorted, it will randomly swap 2 of the elements, and then it'll continue the process of checking again until the entire array is sorted. So if array isn't sorted, kind of shuffle. And how the shuffling happens is, let's say there's a random integer r and there's a random integer q. What it does is it swaps p, I'm sorry, let's say our array here is called a. It swaps ar aq with each other. So that's pretty much the logic behind the algorithm itself. But now let's get ahead and get started writing the actual code for it. Since we will be using random numbers, we need to get started by importing random, and then we start by defining our function for Bozo sort, which is just the actual logic of the sort. A is the parameter here, the argument that the function takes. N is the length of the array here. Now while is sorted, A is equal to false, shuffle. A. So what we're doing here is, as the name suggests, we're just checking to see if the array is sorted, and if it is not, then we shuffle, and we swap the 2 elements with each other. And is sort and shuffle are of course functions that we haven't created yet, but we'll go ahead and create them next. So next up is sorted. A as the argument, and what we do here is let's start with declaring the length of the array. Sorry. And this is where we actually check whether the array has been sorted or not. And how we do that is iterating through the whole array. We check to see if a of I is larger than a of I plus 1. And if it is the case, if it's true, then we return false. And that's because the false says that, okay, this array is not sorted. And if that is not the case, else we just return true. And that is our logic behind checking whether the array is sorted. And it's a pretty simple logic. If at any point in the array, if one of the elements is bigger than the element right next to it, that's clearly not sorted, at least in increasing order. So we go ahead and then we next define the shuffle function. A as the parameter again. The length of A. R here is a random integer between 0 and n minus 1. And the reason that it's between 0 and n minus 1 is because, you know, if you want to swap two of the elements with each other, to enable that swapping, you need to be right before the end of the array. And similarly, we have another random integer, same conditions. And very simple, we just swap it as we saw before. AR and Q are now AQ, comma, AR. And that's pretty much all the logic behind this algorithm. All we need to do now is to set up the driver code, and the driver code is right here. So this is the array that we started with, 3 1 7 2, right? It's not sorted. Bozo sort A. Print %d %a of I, and the comma after it. And that's pretty much it. We are done with the actual logic of this code. So here's our code, and let's go ahead and run it. We can see the array has now been sorted, and you know, it was pretty much instant, right? You see here 0 seconds is the time it took to do this. And you know, it seems like it's a pretty cool algorithm, you know, it was really quick, but that's mostly because it's a small array. And that brings me back to the point where I was telling you about the Bogo sort, which is kind of a companion and close relative of the Bozo sort. What Bogo sort does is actually kind of worse than Bozo sort. Instead of swapping two random elements with each other, it kind of shuffles the entire array randomly and says if it's now sorted. As you can probably tell, the chances of that happening are pretty small, but some people are willing to bet that. I mean, some people are just willing to take the chance. So let's go ahead and increase the length of this array and see how it responds to our so now I have made this 1 2 3 4 5 6 7 8 9 10 11 12 14. I've made this 14 elements long, the array, and let's start this code again. Okay, so it started running, and you know, at least some time has already passed, and we can see 10 seconds and going, and it's still not done. And you know, to be honest, for if you're using any other algorithm, 17-20 seconds is pretty much enough for an array very much bigger than this one. It's just 14 elements. But as you can understand, you know, as long as the number of elements in the array increases, kind of, you know, the effect of the randomness really increases. You can think about it this way. You know, if you have a deck of cards and you check to see whether it's sorted or not, instead of trying to sort it, you just kind of, you know, take two random cards, swap them with each other, and see whether it's sorted now. And clearly, you know, they'll take a long time to do. And that's true in the case of Bozo sort as well. It's still going, you know. We'll actually wait for it to keep going until the end of this video, and who knows, maybe it'll finish, maybe it'll not, and maybe it'll never finish. That is also a very possible probability with Bozo sort. But essentially, um, yeah, the point is that as the number of elements increases, the time that it takes increases a lot. And yeah, that's pretty much how the Bozo sort works. And we're towards the end of the video, and it's still going. And to be honest, I don't know how long I'll have to wait for this to finish. And that is kind of the beauty and the bizarreness of this particular algorithm. Well, I hope you enjoyed it, and have a good day.